Morning, guys. Today we are starting arithmetic. But before that, just a quick recap of what we discussed yesterday. UPSC started CSAT in 2011. They replaced it earlier. There used to be optionals in prelims as well. But they thought that there should be a common paper for everybody to judge everybody on the equal line. And anyway, optionals were there for mains. So they thought optionals were not needed at preliminary stage. So in 2011, CSAT was brought in. It was marks of CSAT used to be counted for qualification purposes earlier, but in 2015, after a lot of deliberations and protests, thought that engineering and mathematics background students are getting, science background students are getting undue advantage there. So they made CSAT as a qualifying paper, and from 2015, it is a qualifying paper where you need 66.66 marks to qualify. But since 2019, we are seeing the difficulty level of paper rising and pattern is clearly changing. So, of course, we discussed why this came into being, etc. So, aptitude is, they thought, important for civil servants of the modern times more than attitude. मुझे भी एक दो। खत्म? सबको मिल गया? So, they thought that aptitude is more important. Aptitude is basically innate learning ability that is due to upbringing, early educations या फिर जो innate abilities होती है, जो genetics हो सकता है या फिर physical capability हो सकती है. So that is more important. That's why these aptitude tests came in, and they test your comprehension ability, general mental ability, and quantitative aptitude, quantitative skills at very basic level, which are essential for any profession as well as civil service. That was the whole idea behind it. But since 2011, as we saw, pattern is changing. How it is changing? Firstly, focus is on basic clarity of concepts in topics like arithmetic, geometry, and primarily mathematization. We saw many questions of past 2 years from these topics, right? Many questions were from these topics, mathematization and linear equation. Then second thing, what we saw, mixing of concepts. So one question contained concepts from various chapters, and you needed to have clarity in all those chapters to solve that question with confidence in it. Otherwise, you couldn't solve. So geometry was mixed with counting figures. Then time speed distance was mixed with ratio proportion, etc. Clocks, etc. So the mixing is very apparent now. Third thing, then we have statement based questions, wherein one question has multiple questions and you need to know all the statements to clearly solve the question, otherwise it is very difficult. Much like GS. In GS also we need to know both the statements, whether they are correct or wrong, then only we can choose the correct option. Fourth thing we saw was regarding comprehension. Earlier comprehension used to be very easy, wherein there used to be longer passage and 4 or 5 questions followed one passage. But now that has changed. Now only one short passages are there, like 100 to 150 word maximum, and following it are 1 or maximum 2 questions, not more than that. Exceptionally, we saw in 2022 paper there were 3 questions under one passage, but primarily that is the thing, 1 or 2 questions per passage. Passages themselves are getting complicated, then questions are not direct. So you won't find answer very directly. Questions are about assumptions, about inferences, about crux of the passage, message of the passage, corollaries of the passage. So these are things which you don't find directly in the passage. You need to derive that as a reader. What is going on in author's mind? What is author trying to convey? And there could be multiple inferences, multiple assumptions. As the questions themselves were clear, which of the following are valid as valid inferences? So there were 3-4 options. So of course, inferences could be multiple. That was very clear. In 5th, we saw shift from data interpretation to data sufficiency. This again we saw. Now data sufficiency was a question in reverse direction. In everything else, we are given some data and we want to find solution. But in data sufficiency, you are not to find the solution. You want to tell which data you require to answer the question. You don't have to find the answer to question. And no new knowledge was required in data sufficiency. Previous questions, previous knowledge was enough. Okay. So this was the change which we talked about, change in UPSC pattern since 2019. So then we discussed relative weightage, which questions are coming. So we saw that around 27 questions is a ballpark figure now. 27 questions are coming from comprehension. Then around 30 questions are coming from mathematics. It includes permutation, combination, probability. These are essentially mathematics topics. But out of those 30, at least 15 questions were coming from arithmetic, which will start today, which is the most important thing. Of course, 15 questions is very high number. So we have to study that well. And apart from that, 10 to 15 questions from logical reasoning. Those questions were very, very standardized. We saw that sometimes some mixing of concepts happen, but most of the times very standard questions from logical reasoning come in the question papers. And then general mental ability, syllogism questions are very frequently appearing, then networks, etc. These are very simple chapters, but general mental ability primarily will deal with permutation combination. This year we saw 7 to 9 questions from permutation combination alone. If you knew that chapter well, you would have scored really well. That was the overview. Finally, we discussed how we will go about this course. First week or next week even, if it requires, we'll study arithmetic in detail, arithmetic, then geometry, and then mathematization and linear equation. These are our foundational blocks of entire course. Okay. If you know these well, everything is very everything will follow very smooth. Everything will be cakewalk if you know these very well. These are confidence booster. These are this is like a refresher course. Whatever you studied in your school years, 5th to 10th, that is concise. That will study in 1.5 years, not more than that. But once you are your foundation is very solid, everything else can be built on it very quickly. Be it percentages, ratios, time, speed, distance, work and time. These are all we will be able to cover in single lecture each once you know these well. That's why we are going slow. If you are feeling that I am going too fast, you can stop me at any time, no issue. You can ask your doubts at any time, no issue. After that, we'll have one comprehension class in wherein we'll discuss all these question types which are asked. What are the meanings of those questions? That is what we'll discuss in that particular lecture. And after that class, in every lectures, in the last 15-20 minutes, we'll discuss 2-3 comprehension. Because comprehension is a skill which you require to build over time. You cannot just start, you cannot just know everything about comprehension in a single day, or I cannot teach you in 1 or 2 classes. It's a skill that needs to be cultivated over time. It requires you to know the vocabulary, read between the lines, know how the author is thinking or what is he trying to say. All these things require practice. Newspaper reading, as you might have been doing. First day when you read the newspaper, it would have been very difficult to understand what the author is trying to convey. But over time, you get used to it. You get used to the subjects. That happens. And look at comprehension from one more point of view. Sometimes those passages are so beautifully written that you can use them directly in your essays or GS paper. Read it from that angle. So your preparation is not compartmentalized in any way. Everything can be used anywhere. But you just have to keep open mind that how can I use in some other place. If the passage is about economics, that is your economics revision as well. You can use that knowledge in your GS3, in your prelims GS paper 1. Or if the passage is about, let's say, environment, every year we are getting passage on environment somewhere or the other. That is your revision of environment, current affairs, that you can use in your essays as well. Okay, so we'll look at comprehension from that angle. So that is about the course. I'll give you home assignments after every class, and we'll have 5 classes a week, 2.5 hours. We'll finish before 19th February rather. We'll try to finish before that, but that is the deadline. End date 19th February. If required, we can take extra classes. If required, if you want, we can have doubt sessions at our convenience. We'll decide that. Okay. If you have any doubts, you can ask now, or We'll start with our today's topic, arithmetic. No doubt. Okay. UPSC has mentioned the syllabus. I have repeated it for your sake. They mention basic numeracy, which means numbers and their relations, orders of magnitude, etc. And in bracket class 10 level. That is all they mention. And then they mention data interpretation, charts, graphs, tables, data sufficiency, etc. So syllabuses are definitely not in detail. It is that etc. that contains entire syllabus. It is open-ended syllabus. We will start with number system and number line. Mathematics, essentially it is about finding patterns in the nature. Our brains have evolved to see patterns and recognize them. Whatever we want to see, we can see. So if you are looking for, let's say, yellow cars, and you tell your brain that I'm looking for yellow cars, you'll immediately start noticing all the yellow cars. That is how our brains have evolved, to see the patterns in nature. And that is what mathematics is, recognizing those patterns, representing those patterns into some language. And if the language is not there, inventing that kind of language. Algebra is one such language, and number system is another such language. Or number system, you can say, is part of algebra or arithmetic or number theory. So these are all languages to represent what is already there in the nature, or the patterns. We want to represent the pattern. And it all started with counting. There is evidence that at least 50,000 years, humans have known how to count. They represented it in very crude form. Like, for example, if there is cattle, so you can represent one cattle with one stick, and you keep on representing it like that. That has been the way, but it all started changing once the civilizations got built and mathematicians got into the act. Okay. There are different kinds of numbers which will start. First are natural numbers. Why the word natural? Because that is how we naturally count. एक मिनट एसी लगा अपने लिए हम लोग के लिए. Natural numbers are called natural because that is how humans naturally count. 1, 2, 3. They want to count animals. If they want to count how much, let's say, taxes one has to pay, how many bighas of land one has, all these economic data, all these accounting data, how many people are there in the clan, all this data requires you to count. That is how societies get formed, and that is how it all began. So this is the natural way of counting. 1, 2, 3, 4, ... So these are natural numbers. We saw these terms are important. Huh? They are getting asked in the questions. You need to know what these terms mean. So natural numbers are how we naturally count. 1, 2, 3, 4. These are all natural numbers. But which number is not there, which we are very, very used to? 0 is not there. Story of 0 is very, very intriguing. Civilizations have known 0. You might have heard that Indians invented 0, right? You might have heard that. But that is not exactly correct. People, or rather other civilizations, knew this concept. They used it as a placeholder. For example, Mayan civilization or Babylonian, they knew what 0 was. So for example, they knew what is difference between these two. These are two different numbers, but they use 0 as a placeholder, like a comma. It just left the place blank, or they use some symbol or the other to represent it as a comma. We write in English language, we write commas, or in any language we write commas. Commas have no meaning. You cannot operate on commas. Commas are not numbers. So they used 0 as a placeholder just to differentiate between the numbers. But the genius of Indian mathematicians, or Brahmagupta in particular, was that he could use 0 as a number in its own right. Okay. What does that mean? It means that instead of having numbers from 1 to 9, that is how many numbers we have in decimal system, non-zero numbers that were known to others as well. For example, Romans. You might have known these Roman symbols like I, 2I, I, V. These are Roman numerals. There is no 0 in them anywhere. You can still operate on them, but there is no 0 in them. So that is where Indians differed. These were Roman symbols for numbers. Indians knew this symbol. They added 0 as a number in its own right. And now you could operate on zeros. Now you can use zeros in writing the numbers. You can writing the numbers in very efficient way, very in small size. So earlier, if you want to write, let's say 10 lakh, in Romans there are like symbols M and C, etc. Those are symbols. I don't know if you know what these mean, but some of them means 50, some of them mean 100. So you have to keep writing. So if you want to write 10 lakh, it goes something like this long. But if you have 0, you can just write this, or even more in simpler way, 10 raised to 6. This was the power of 0. And why we could do that? Because we could operate with 0. So Brahmagupta himself gave rules of zeros. Like he said, 1 plus 0 is 0. Sorry, 1. 1 minus 0 is 1. Then anything into 0 is 0. These all rules were given by Brahmagupta, except one rule, division by 0. He didn't give that rule. That came with Bhaskaracharya 500 years later. Brahmagupta was in around 7th century. 500 years later, there was Bhaskaracharya who said that something divided by 0. He then said that this is Anant. These both terms, Shunya or Anant, they are coming from Indian philosophies that were before those times. So Shunyavad, Shunyata was there in our ancient scriptures, be it in Hinduism or Buddhism. In Buddhism, there is theory of Shunyavad. In Hinduism, there is a concept that everything in the universe started from Shunya or 0. So that's where they were coming from. So it was not unusual or unnatural for them to think of 0 as a number in its own right. But and this as well, Ananta. Ananta is a concept pretty much there. So in Bhagavad Gita again, they say that God is Anant or infinite. That is where Brahmagupta, Bhaskaracharya was coming from, and he was giving rules for this. Okay. So that is the rough background of how 0 came into being. So can we say 0 was not really invented by mathematicians? 0 was used by Indian mathematicians as a number in its own right, which democratized mathematician, which revolutionized mathematics beyond recognition. Because we can't do anything now and write it very, very concise way, and everything was just exploded after that. Fine. And apart from that, Brahmagupta gave these rules of zeros. But Indian mathematicians also knew about positive and negative numbers. Europeans discarded negative numbers as something irrational or impossible for at least 1000 years after Brahmagupta. Till 14th, 15th century, European mathematicians were afraid of negative numbers. But Brahmagupta gave rules of operating on negative numbers as well. He treated them as runa or debt. They were talking in terms of debts and all. So if I am to give you 5 rupees, it means I have minus 5 rupees, something like that. That's why again it was not unnatural to them. It was very, very apparent to Indian mathematicians. Okay. So coming back to our natural number system and whole number system. So these are natural numbers. These are whole numbers. Okay. These terms are important. Rest of the story is relevant not for your CSAT, but you can use that somewhere else. Like when your question could come in GS3, contribution of ancient Indian mathematicians or ancient Indian scientists. So there you can mention about Indian mathematics, Indian astronomy, you can mention about Indian medicine, Indian chemistry. These are all aspects you can talk about. There you can mention these things. In short, not in that much detail, in short. Okay. Do you know anything about Indian medicine? Charak Samhita, Shushruta Samhita. We had preliminary plastic surgeries, then operations, cadaver dissections. These are all things mentioned in Sushruta Samhita. Charak Samhita is there. Ashtanga Ayurveda is there. Ashtanga Ayurveda. I think there is one of the. There are 3 books, primary books in Ayurveda. These are 2 Samhitas, and there is one more book. Find it out. Find out. Find. This could be relevant question because very relevant question, right? You can always be asked this question. Contribution of ancient India in field of science and technology. Very good GST question. Then you can talk about Indian astronomy. What can you say about Indian astronomy, ancient Indian astronomy? Don't talk about astrology because they are 2 different fields. We are talking about astronomy. Find out. Then these are natural numbers, these are whole numbers. After that, we talk about integers, wherein we include negative numbers as well. We saw that Indian mathematicians were very well versed with negative numbers. And as a proud inheritors of that legacy, we should also be well versed with negative numbers. These are the integers. Typically, we represent them by this capital Z. So 3 things, 3 systems we saw: natural numbers, whole numbers, and integers. And we can represent everything on number line. Number line is this straight line going in both direction, where there is 0, and at units at constant distance there is 1, 2, 3, 4 on this side, and -1, -2, -3 on this side. Numbers on right side are bigger than numbers on left side. These are positive numbers, 1, 2, 3, 4. These are negative numbers, -1, -2, -3. 0 is neither positive nor negative, right? If I say non-negative number, what would those be? Those be 0 to whatever there is the right side of 0. If I say non-positive numbers, then I am talking about 0 and whatever is there on the left side of 0. So these are integers on number line. This number line is called real number line. When we include whatever numbers are lying between those two, all the gaps. There are gaps between 0 and 1, 1 and 2, 2 and 3, etc. In this gap, you have 2 kinds of numbers. There are rational numbers and irrational numbers. We will study them when we study fractions. Fractions are rational numbers, and those numbers which are there but they are not fraction are called irrational numbers. Irrational numbers have not been asked in the examination yet, so we will study them in the very brief. In the end, there is one passage on irrational number. That is all you need to know for now about irrational numbers, but we'll do that in the due course. Okay. Now look at the question given in the booklet. CSE 2020 का question है. Question is about odd numbers and even numbers. Do you know what are odd numbers and even numbers? Even numbers are all the numbers which are divisible by 2, like 0, 2, 4, -2, -4, etc. Odd numbers, those are not divisible by 2, like 1, 3, 5, and on this side -1, -3, -. These are odd numbers. These are even numbers. All the integers can be divided into odd numbers and even numbers. Similarly, all the natural numbers or all the whole numbers would be divided into odd numbers and even numbers. Which is the smallest even number in whole numbers? 0. 0 is an even number and smallest odd is 1. If I talk about natural numbers, then smallest even number would be 2. In the integers, what would be the smallest even number? There would be no smallest even number because this goes to minus infinity. So there is no smallest or largest, right? But if I say what is the largest non-positive even number in integers? Non-positives are 0 and all the things. What is the largest? 0. 0 is the largest because others are negative numbers. Whatever in the left is smaller, whatever is in the right big is bigger. Okay. These are all variations where I can ask you statements and you need to answer. All the variation like the smallest non-positive number, that would be again 0. Largest non-negative, non-positive would be 0, or smallest non-positive non-existing, etc. etc. These are all the word plays that can happen. Find the question. How many odd numbers are followed by odd number in the above sequence? Very simple question. You just have to look for odd number and count how many times odd number is following the odd number. बस गलती मत करना, इसमें गलती करोगे तो प्रॉब्लम, -3.5 तक चला जाता है ना, -0.83 हो जाता है हर कर दिया, नहीं आ रहा, एवरीबॉडी इज गेटिंग सिक. Online students, Vivek, Swapnil, Shanky, you also solve and let me know the answer. Your participation is also required. Hmm. 6 are there, right? Everybody is getting 6. So, correct. Not because you are getting 6, it is correct answer. It is independently correct answer. It is good thing that question booklet has not been uploaded. अरे अपलोड हुआ होगा यार सेक्शन में, अपलोडेड सेक्शन में देखो. Swapnil has it, so it would be uploaded on the portal. Please check. Okay, next question देख लो, CSE 2022 का. Just question पढ़ लो. We are not doing that right now. We'll do that when we study equation. As I said, question says sum of 3 consecutive integers is equal to their product. So you need to know what are integers. Other than this, if you don't know, you can't solve that question because the answer would be different. If we are talking about natural numbers, answer would be different in whole numbers and answer would be different in integers. Okay, we'll solve this when we study equations. Come to the next part, place value system. We are primarily dealing with decimal system where base is 10. There are other systems as well, like base 2 system is binary system that is used in your computers. There is octal system, there is hexadecimal system, there is base 60 system which was used by Babylonians when they were talking about mathematics. Question, how can, अरे यार upload हुई है ना स्वप्निल, please check upload हुई है कि नहीं booklet, because I don't have it on the screen. I have to use the screen na. You have access to the portal, right, Vivek? It is uploaded. Swapnil, can you tell him where it is uploaded? Please tell them which section it is uploaded. Okay, live class section. Good. We're coming to our place value system. We all studied this in our schools, but let's just repeat it. In decimal system, there are two parts of any number. There is decimal point, there is something to the left of decimal point, and there is something to the right of decimal point. This is called units place, this is called tens place, hundreds place, thousand place, and so on. And here similarly 1 by 10, 1 by 100, 1 by 1000, and so on, right? In India, Aryabhatta was the one who gave place values in his seminal work Aryabhatiya. Anyway, that is not relevant. I just fine. So whatever number is appearing here, it is a base 10 system. Decimal system is base 10 system. It means we have 10 symbols from 0, 1, 2 up to 9. These are 10 symbols, and when we want to write next number that is appearing, which is 10, after 9 10 will appear, so we write 1 0. Of course, when we are writing 1 0, this 0 has place value 0, it is coming in the units place, but this 1 that is coming in the tens place, its place value is not 1, it is 10, right? So then after 1 0, 1 1 would come, then 1 2 would come, 1 3 would come, and so on. So place value of these 2 or 3 or 1, there itself, place value of 3 is 3, place value of 2 is 2, place value of 1 is 1, but place value of this 1 is again 10, this 1 is 10, this 1 is 10. So if I am writing something like 23, place value of 3 is 3 and place value of 2 is 20, right? I am adding one more 2 here, let's say. So place value of this 2 is 200, right? This is what we mean by place value. In binary system, we have only two symbols, 0 and 1. 0 and 1. If I want to write the next number, which is 2, I would write 1 0. This is how we write 2 in binary system. Place value of this 0 is 0. Place value of this 1 is 1 into 2 raised to 1, which is 2. Here it is 1 into 10 raised to 1. We have not studied powers, but you must be familiar with the symbols. Anyway, when we will study power, this will all become further. So this is our place values. This is units place, this is tens place, this is hundreds place, and so on. Similarly, this is 1 by 10, 1 by 100. Whatever number is here, we multiply it with this particular factor, and we'll get the place value. So can you tell me place value of 3 in this number? 300, place value of 4, 40, place value of 10, 1 is 1000, 2 is 20,000. Clear? So if I forget about the numbers and write some number in symbolic form, let's say ABCD. What is place value of D? D itself, place value of C, 10 into C, right? Place value of B, 100B, place value of A, 1000. Clear? Only using this fact we can solve many questions. For example, read the question CSE 2022. 2020, 2022 नहीं 2020 का है ये. And this can happen for negative numbers as well. Like there is integral part of the decimal number, This is integral part and this is fractional part on the right side of decimal. Okay, Vivek, no issue, no issue. These are any two decimal numbers. Here, this is called as integral part. This is called fractional part. This is fractional part. Whatever comes after decimal place. So it is integral part is 57. Fractional part is 0.13. 0.13. Here, integral part is minus 57 and fractional part is 0.13. Again, same. Just terminologies. Now you can read the question. The question says difference between a two-digit number and the number obtained by interchanging the position of digits is 54. So there is some two-digit number we don't know which. So we take symbols. That's why I said that how to deal with symbols. So let us take number as PQ. How can we write PQ? PQ is equal to 10P plus Q. Place value of P is 10P. Place value of Q is Q. So 10P plus Q. Right? Fine. Now we reverse it. We write QP. This is what reversing it, which is equal to 10Q plus P. No doubt, no doubt here. We are just writing it in terms of its place values. This is how we write place values. Okay. Now let's read the question. Difference between these two is 54. We are finding difference minus. What is the difference? 10P minus P, which is 9P, and Q minus 10Q minus 9Q, and it is given as 54. Given whenever the question says that there is a two-digit number and number found by reversing it, you do this. We'll do multiple questions. This is the first question. That's why you might be feeling something new or uncomfortable. It's not so. It is very standard practice to do this. So in this, I can take 9 common. I can write this as 9 into P minus Q is equal to 54. Now I can divide both places by 9 because this is in multiplication. So I can divide. 9 will get cancelled here. We get P minus Q is equal to 6. Okay, this is one condition we got from the question itself. Now, first statement is sum of two digits of the number can be determined only if product of two digits is known. Second is the difference between two digits can be determined. Second statement is obviously correct. We determine difference between digits. That is what we determined, right? This is difference between the digits. So second statement is correct. And first statement क्या लग रहा है? Only होता है तो 98% तो wrong ही होगा. Only is there, extreme statement है. And I said this in the previous class and I'll repeat it 100 times at least in the duration of this course. If we have two variables, how many equations do we need to solve them? Two independent equations. One we got. We want to know what is P and what is Q. One equation we got. If we get one more equation which is not same as this equation, we can solve. That second equation can be anything. We don't care what is second equation, we just need it different from this particular equation. So, अब statement 1 क्या बोल रहा है? Sum of two digits of a number can be determined only if product is known. It is not so. Anything, you give me any equation and we can determine the digits and sum of digits. Only तो गलत ही. Maybe you are not appreciating this fact, but you will. I am just trying to tell you, using just place values, you can solve the question. First statement is wrong. Why? Because one, it is extreme statement. तो मोस्ट ऑफ द टाइम उसको रॉन्ग होना ही था। एंड सेकंड, एंड उसका एक्चुअल रीजन इज दैट बिकॉज वी नीड एनी वी आर फाइन विद एनी टू इक्वेशंस which are independent to solve two variables, to find out two variables, and we don't necessarily require particular equation. So the statement 1 is talking about only one equation and they are saying only this equation can solve. ऐसी बात नहीं, कोई भी दो इक्वेशन होंगे तो चलेगा. First statement is wrong, second is obviously correct. So the answer is B here. PQ and QP are digits. So like PQ and QP can be 1 2 and 2 1, something like this. That is what the question is saying. P and Q are symbols here. Reverse of PQ is QP. That is what the question is. Reversal of digits, interchanging the position of the digits. This is what reversal means. Next question देखो. The ratio of two-digit natural number to a number formed by reversing its digit is 4/7. Ratio is basically division. Okay. What it is saying? PQ divided by QP is equal to 4/7. That is what it is saying, right? So you can write PQ as this, QP as this. You can write 10P plus Q divided by 10Q plus P is equal to 4/7, right? And then you can cross multiply. If you are feeling uncomfortable with all this, it is okay. We have just studied place value system. We have not studied operations. We have not studied addition, multiplication, division. We have not studied how to deal with fraction. We have not studied equations. But when we will do study, you will be very comfortable in all this. If at all you are feeling left out or somewhat confused, it is okay. Don't worry. Here you only have to cross multiply and get equation. So you can get one equation from there. Questions are there in that booklet only, where in whichever topic we are studying, under that topic only we are covering these questions. These are all PYQs. From here you will get one relation between P and Q, and question asks how many such pairs are possible. So we have one, P and Q could be any of the digits, like from 0 to 9. How many of them are possible which are following this particular condition? That's what we have to find. Here again you can simply cross multiply 7 into this, 7 into 10P plus Q is equal to 4 into 10Q plus P. So this is 70P plus 7Q is equal to 40Q plus 4P. You can subtract 66P is equal to 33Q. So 2P is equal to Q. This is the condition. We want to find two-digit numbers. So none of P and Q can be 0. Then because QP would be otherwise single digit number. We want two-digit. So Q can be 1. Sorry, P can be 1. Then Q is 2. P can be 2. Then Q is 4. P can be 3. Q is 6. P can be 4. Q is 8. और 5 होगा तो ये 10 नहीं हो सकता ना. Q is a digit. Q has to be one of 0 to 9. So these are only 4 possible. Okay, place value से solve हो सकता है. Just have to write the ratio, just have to cross multiply and find the condition, and which of the digits satisfy this condition, that is the required answer. Fine. There could be more questions on place values which would follow as we go along. For now, place value is clear, no issues. Then we have mathematical operations. I have given somewhat technical definition of operations. Operations is basically they take two numbers, they do some kind of operation between them, and then they give you one output. This is what operation. Addition is one example. So they take two numbers, let us say 2 and 3. Addition operation does 2 plus 3 and gives you output which is 5. This is what operation. Mathematical operation is they operate on two inputs and give you two or more inputs, give you one output. Fine, that is what operation is. We study fundamentally 5 operations: addition, multiplication, division, subtraction, and powers or exponents. These are the 5 operations that are relevant to us. Now, what is addition? Addition is sum of the two values when we combine them. We are talking in terms of numbers. When we add two things or when we take sum of two things, that is what addition is. In number line, we can say addition is going to the right. So if I am at the 0 and I have to add 3 to it, I have to go 3 places to the right. 1, 2, 3. So 0 plus 3 is 3. If I am starting at minus 3 and I have to go plus 9. So I go 9 places to the right. From minus 3 to minus 2, minus 1, 0, etc. So that is how you can visualize addition. Addition is going to the right, and subtraction is exactly reverse operation of addition, going to the left. Right? Addition, subtraction. सब school में पढ़ा है. We are just kind of revising it so that there is no issue. What is important is properties of addition. Refer the booklet. Addition of two even numbers is an even number. Minus 2. What is it? Minus 3. Yeah, it is. This is what? This is subtraction. Addition and subtraction. So we are talking in terms of addition and subtraction. This plus minus will become minus. Fine. This is equivalent to minus 2 minus. So you go to left. Minus 2, minus. Addition is going. Addition by positive number is going to the right, but addition by negative number is essentially subtraction. It is reverse operation of going to the right, or addition by positive number. Addition by negative number is going to the left. That is essentially subtraction. That is how we define subtraction. Subtraction is reverse operation of addition. Properties are more important. Addition of two even numbers is always an even number. So 2 plus 4 is 6. 7 plus 4 is 11, which is not an even number. Even number plus even number is an even number. Okay. Those even numbers could be positive or negative, no issue. So minus 4 plus 2, minus 2, still an even number. Minus 4 plus 4, 0, still an even number. Any even number added with even number is even number. If you are getting any time, if you get confused, take an example and follow that. Then even number plus odd number gives you odd number. 1 plus 2 gives you 3. 3 plus 6 gives you 9. Minus 1 plus 2 gives you minus 1, which is odd number. Right? Then addition of two odd numbers is odd and even number. 3 plus 5 is 8. 1 plus 3 is 4. Odd plus odd, even, even plus even, even plus odd, odd number. Whenever you get confused, take an example and follow that. That would be pattern. Addition of two integers is always an integer. Right? Addition of two natural numbers would always be a natural number. We are talking about addition. Subtraction, we are talking separate. Addition of two natural numbers will always be a natural number. Addition of two whole numbers will always be a whole number. Then addition is associative and commutative. What do we mean by this? Addition of a plus b plus c is equal to a plus b plus c. It doesn't matter which you do first. Here a plus b is we are doing first, and then we are adding that number to c. And here you are adding b plus c first, and then you are adding it to a. For example, 2 plus 3 plus 5 is equal to, what is this? 5. 5 plus 5 is equal to 10. In this way, if you do, okay, 2 plus 3 plus 5 is equal to 2 plus 5 plus 3, 8 is equal to 10. So, which part of the addition you do first doesn't matter. You can do it in any which way. And secondly, commutative means order doesn't matter. For example, a plus b is equal to b plus a. This is what we mean by commutative. You can do it in any which order you want. You know all these things from your school days, but in mathematical terms, these are called associativity and commutativity. They can ask these terms. That's why basic terms at least you should be familiar with. This is what we mean by associative. That is what we mean by commutative. It is not some rocket science. It is just what we know already. Fine. Then addition with decimals. Can you add two decimal numbers in decimal system using including fractions as well? For example, let's just add these two numbers for my sake and for yours. You might feel this is very simple. Just do the exercise for once and we'll go ahead. Add these two numbers. What is it? Do you know how to carry? Everybody can do this addition, no? Or do I need to explain it? No, no? 8 plus 4, 2. Carry over 1. 11, 1. 8, 1. Right? Similarly, in the decimal, 5 plus 6, 13. Right? 7, 4, 1. This is how you add two numbers, even when there are decimal points involved and there are no decimal points. It doesn't matter. You can add simply from right to left. Right? Then subtraction. Subtraction is taking away something or moving to the left on the number line, or addition in reverse operation of addition. Again, let's go with over the properties of subtraction. Subtraction of two even numbers is even number. Yes, 2 minus 4 is minus 2. 4 minus 2 is 2. Two even number, subtraction is even. Even minus even, even. Then subtraction of two odd numbers. Odd minus odd is again even number. 5 minus 3 is 2. 7 minus 5 is again 2. These are all even numbers. Then odd minus even या फिर even minus odd, क्या होगा? It would be odd number, right? Then subtraction of two integers is always an integer. Imagine you are starting on any integer on that number line we drew. Any integer if you are starting and you are subtracting or adding some integer. You are either going right by one unit, some units, or you can go left by some units. You will still land upon integer only on the left or on the right, but you will land upon integer only. So integer subtracted from integer is always an integer. But can it be said for natural numbers? Natural numbers are starting from 1. If you start from one particular number and you want to subtract something. So essentially you have to go to left, right? Subtraction is going to the left. Is it a guarantee that you will always stay within natural numbers? No, you can go to the integers. So natural number minus natural number is not always a natural. Whole number के लिए भी ये true नहीं है. Whole number minus whole number can also be a negative integer. So that is also not true for whole numbers. We have written that subtraction of two natural numbers is not always a natural number. Then subtraction is associative but not commutative. Commutative क्यों नहीं है? 2 minus 5 is not equal to 5 minus 2. 2 minus 5 is minus 3. 5 minus 2 is 3. These are not same numbers. They are different. Subtraction is not commutative, but associative है. वो कोई problem. तो वो जो ये वाली चीज थी, here you can have minus 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 and result will stay. Associativity valid है, commutativity नहीं. ठीक है? I'm not going too fast ना. If you have any doubt, you can stop me at any time. Then we go to multiplication. Multiplication is essentially a repeated addition. When we multiply things, we add repetitively. So 2 into 3 is same as 2 plus 2 plus 2. 2 we are adding 3 times. That is what multiplication is, repeated addition. So I have given example of 9 there. 9 into 6 is 9 plus 9 plus 9, 6 times, which is same as 54. The numbers that are multiplied are called factors and the result obtained after multiplication is called product of. So here 2 into 3, which is 6, is called product of 2 and 3, and these are 2 and 3 are factors of 6. Factors, products. Now दो नंबर को मल्टीप्लाई कर सकते हो. Are you familiar with the process of multiplying two numbers? तो वो कर लो. 569 into 63. What happened? कर सकते हो ना ये? सबका आ रहा है वही आंसर 35847. फाइन. कैन यू मल्टीप्लाई विथ नेगेटिव नंबर्स? वो रूल्स पता है हमें. पॉजिटिव नंबर इनटू पॉजिटिव नंबर, इट गिव्स अस पॉजिटिव नंबर, राइट? पॉजिटिव इनटू नेगेटिव गिव्स अस negative number. Negative into negative gives us positive number. These are rules for multiplication with negative numbers. Multiplication ऐसे ही करना है, बस जो साइन है वो ऐसे एडजस्ट करना है. प्लस इंटू माइनस या फिर माइनस इंटू प्लस है तो माइनस करना है. माइनस इंटू माइनस, प्लस इंटू प्लस इज प्लस. कैन यू मल्टीप्लाई विथ डेसिमल्स? डेसिमल से मल्टीप्लाई करना जानते हो? रूल्स टू मल्टीप्लाई विथ डेसिमल. So you just multiply two numbers as if there is no decimal point and combine the decimal points of two numbers. Add the decimal points of two numbers. So if you want to do 21 into 3, which is 63, 2.1 into 3 is again 63. There is one decimal point. So we start from right, give one decimal point. 2.1 into 0.3, still 63. But here 1 plus 1, two decimal points are there. So we give it at here 0.63. 0.21 into 0.3, which is again 63. But 1 plus 2, 3 decimal points we want. So 1, 2, if there is nothing, add 0, right? 0.21 into 0.03, still 63, but we want 4 now, 2 from this, 2 from this. So 1, 2, 3, 4, this would be answer. ठीक है, ऐसे हम डेसिमल से मल्टीप्लाई कर सकते हैं कोई भी नंबर्स को. ओके, कंफर्टेबल विद ऑल दीज रूल्स? Okay. Online students, Swapnil, Shanky, Vivek, Janardhan, if you are all following, tell me that you are following, otherwise stop me. Okay. So this while we are multiplying with decimals, we just multiply as if there is no decimal point involved, and then we adjust decimal point according to these rules. That how many, however, whatever be the number of multiplications we are involved, just whatever that follows after decimal points, we add those numbers and we give decimal points, adding all those decimal points together. For example, here 21 into 3 is simply 63, but 2.1 into 3, we assume that there is no decimal point, so multiplication would be 63, and here there is no decimal point, here there is one decimal point, so we write 6.3. Similarly, here we multiply as if there is no decimal point, we get 63, and here there is one decimal point, here there is one digit after decimal point, so there are total 2 digits after decimal point. So we have to do decimal points from the right, we have to leave 2 digits. So you have to give 1 and 2, here decimal point would come after 0.63. Here there are 2 digits after this decimal point, 1 digit after this, so total 3 digits should come after decimal point in this particular product, 0, 6, 3. There was nothing here, so we added 0, because place value of this 0 is 0. Place value of 0 is always 0, 0 into anything is 0. Again here there are 2 decimal points, 2 digits after decimal points, here there are 2 digits after decimal point, so in the product there should be 4 digits after decimal point, so we have 6, 3, and because there is nothing, we add 2 zeros, so 0.0063, that would be the product. If we are dealing with 3 numbers, multiplication of 3 numbers, again those will get, for example, 2 into 3 into 4, what is it? 24. So 0.3, 0.2 into 0.3 into 0.4, it would be total 3 digits after decimal point, 1 plus 1 plus 1. So here would come decimal point would come 3 digits from the right. So after this decimal point there should be 3 digits. One is, there were only 2, so we added 1 0. 0. So 0.02 into 3 into 0.004. Can you do this? Product is still 24. Where would decimal point come? 1, 2, 3, 4, 5. Here there are 2, and we need 5. This is how you multiply, even if there are multiple factors involved. Product is taken like this for decimal. If there is, instead of 0, there is something else, that also doesn't matter. You just multiply as if there is no decimal point and just add total digits after decimal points and do that to the right. So do that to the product. Okay, clear? Multiplication with decimals. Okay, great. Now look at the properties. Multiplication of two numbers is even if both are one number is even. So what we are saying, even into even is even, even into odd is also even. Why? Because 2 is factor, 2 is factor of left side, it will be factor of right side as well. We are just taking product. For example, 2 into 3, 6, 2 into 9, 18, all are even numbers. Multiplication of even number by anything is even number. And odd into odd, it will be odd now. 3 into 5, 15. It is not an even number because 2 is not a factor of anything on the left hand side. If 2 is not factor of the factors, it will not be factor of the products, right? apart from that, multiplication of two natural numbers will always be natural number. In multiplication, essentially it is repeated addition. So we are going to the right. Multiplication of two natural numbers is natural number always. It cannot go negative or zero. It's zero. Natural number will stay within the natural numbers. Multiplication is associative and commutative. That is there because addition is associative and commutative. Multiplication is essentially addition, repeated addition. Okay. Fine. Then we have multiplication by 10. What is multiplication of any number by 10? 2 into 10, 20. एक जीरो ऐड हो जाता है 2 के आगे. मल्टीप्लीकेशन बाय 100 क्या होता है? 2 जीरो ऐड हो जाता है. Multiplication by 10, 100, 1000, 10,000. Just you add zeros to the end, right? So 5 into 10,000 क्या होगा? 5 के आगे जितने भी जीरोज है वो ऐड हो जाएंगे. 50,000. 10 की कोई भी पावर से मल्टीप्लाई करना इजी होता है. 10 से, 100 से, 1000 से. यू जस्ट ऐड जीरोज. 10 से मल्टीप्लाई करना एक जीरो ऐड करो. 100 से करना है 2 कर लो. 1000 से 3 कर लो. 10,000 से 4 जीरोज ऐड कर दियो जो भी नंबर है उसके आगे. तो 12.5 इंटू 100 क्या होगा? 2 जीरोज ऐड करने हैं. 2 जीरोज यहाँ पे एक जीरो पहले तो डेसिमल एक राइट आ जाएगा फिर एक और राइट जाएगा. हाउ डू यू मल्टीप्लाई बाय डेसिमल्स का हमने देखा. यू जस्ट मल्टीप्लाई एज इफ देयर इज नो डेसिमल पॉइंट एंड देन एडजस्ट फॉर डेसिमल्स. 12500 एंड यहाँ पे एक डेसिमल है तो वो यहाँ पे आएगा. Essentially we shift to right by 2. Decimal point is shifted to the right by 2 when we multiply by 100. Multiply by 10 एक से शिफ्ट होगा. Multiply by 1000 3 से शिफ्ट होगा राइट पे. यही रूल है. रूल वही है. जस्ट फॉर आवर सेक ऑफ सिंप्लिसिटी हमारे दिमाग में हम ऐसा कनेक्शन बना रहे हैं. मल्टीप्लीकेशन बाय 10, 100, 1000 ये बस एक जीरोज ऐड होंगे या फिर अगर डेसिमल है तो एक राइट शिफ्ट हो जाएगा. दोनों एक ही चीज. अब वो क्वेश्चन देखो CSE 2020 का. हाउ मेनी जीरोज आर एट द एंड ऑफ द फॉलोइंग प्रोडक्ट. जीरोज मतलब 10. जीरोज मतलब 10 की कोई पावर 10, 100. हमें बताना है कि हाउ मेनी टाइम्स 10 appears in that particular product. I'll write the product. हम लोग ट्राई करो. We have to tell how many zeros appear at the end of this product. In other words, we have to tell how many times 10 appears in this product. समझ गए दोनों क्वेश्चन सेम ही है. That is important to understand. Once you understand that, it is very easy question. Let us see. I don't recall the exact answer. We'll solve this together. First, what is 10? 10 is 10 into 1. It is also 2 into 5. Right? We have to tell how many times 10 appears in this format or this format. Now, as a 10, it appears how many times? It appears once here, 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 6 times. 6 वैसे हो गए. अब 2 into 5 देखना है जो 10 नहीं है. अब 10 में 2 into 5 नहीं देखना. ठीक है. Now let us look at 5. 5 is appearing once here, once here. ये नहीं देखना है अभी. अभी वो चला गया. once here, then twice here. 25 is 5 into 5. 1, 2, 3, 4, 5, 6, 7. यहाँ पे भी 25 है, राइट? कितना हुआ था? 8 हुआ ना? राइट? 5 into 10. 10 तो पकड़ लिया हमने, ये 5 पकड़ना है हम. 8 हो गया. 2 तो बहुत बार है, 2 तो आ ही जाएगा कि इवन नंबर्स उतने हैं. नहीं आ रहा? यहाँ पे 2 बार आ रहा है 2. इस 4 ना? हाँ, ओके. 10 we have already counted. 2 into 10. This is 3 into 10, ये चला गया. This is 4 into 10. This is 5 into 10, वो चला गया. This is 6 into 10. 1, 2, 3, 4. So 2 is appearing 4 times. So limiting is 2. 2 आना चाहिए. 2 into 5 होगा तभी 10 हो जाता. तो ये 4 और ये 6, तो 10. सिंपलर थिंग कुड हैव बीन, ऐसे छोड़ ही दो, सबको 2 and 5 के टर्म्स में लिया. दैट कुड हैव बीन इजियर. वो प्राइम फैक्टराइजेशन की तरह से हो जाता. दिस इज प्राइम फैक्टराइजेशन ऑफ 10. दीज आर टू प्राइम नंबर. तो उस टर्म्स में बहुत इजी हो जाता है. ये दोनों का टैब रखना थोड़ा डिफिकल्ट है. ब्रिंग एवरीथिंग इन टर्म्स ऑफ 2 and 5. That is much easier. So you can write 1 into 5 into, you can write this 2 into 5, you can write this 3 into 5, this is 4 into 5, 4 is 2 square, 2 into 2, 2 square into 5, this is 5 into 5, this is 2 into 3 into 5, this is 7 into 5, this is 2 cube into 5, this is 3 square into 5, this is 2 into 5 square, 5 into 11, this is 2 square into 3 into 5. Now you just count 2 कितनी बार आ रहा है, and 2 raised to 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 2 raised to 10, 3 raised to something, we don't care, and 5 raised to what? तो 10 कितनी, 10 कितनी बार आएगा? 10 बार आएगा, जो भी इनमें से छोटा. ये 2, ये क्या होगा फिर? 2 raised to 10 into 5 raised to 10 into 3 raised to something, 5 raised to 4. This 10. ये 5 का 5 ऐसा रहेगा. अभी इसके साथ कोई 2 नहीं है 10 बनाने. 10 बनाने के लिए 5 into 2 दोनों भी चाहिए. समझ गए या फिर से समझा दूं? हाँ, there is some confusion on your face. This thing here. I want 10 na. So question is how many zeros appear at the end of the product. What is 0? 0 is nothing but 10. The question is how many times 10 appears in the product. What is 10? 10 is 2 into 5. I am converting everything in terms of 2, 3, 5, basically prime numbers, and however many times 2 into 5 I get, that many times I will get 10. So I am just counting 2 into 5. So here 2 raised to 10 is there, 5 raised to 14 is there. For 2 into 5, I can take 2 raised to 10, 5 raised to 10, and this 5 raised to 4 will remain. So this is what 10 is. This is 10 raised to 10 into something. There is no more 10 appearing in the rest of the product. So these are the number of 10s. This is 10. That is what we do. Here, whatever number less, so if 5 was less, we could have left some 2's out and then combine 2 and 5. Because here are more 5s, we just combine 2 with 5 and 5 are left. being left out. It will be repeated when we study prime factorization. Maybe today, maybe tomorrow, but it will be repeated very soon. Don't worry. If I don't repeat, you remind me tomorrow and I'll repeat this question. This is very easy question. Just have to count number of 2's, number of 5's that are appearing, and whatever the lesser number is there, that would be number of time 10 appears. Basic concept is number of zeros in the end is nothing but how many times 10 appears in the product. That is the basic concept. Rest of it is counting. The next question, if ABC into DED is equal to ABC, where ABCDE are different digits, then what are the values of D and E? Here they want you to tell what is D and what is E. 4 options are given. Simplest way could be just put 4 options and try it out. Now just think, looking at options, D and E are 0, 1 or 2, right? Can D be 0? D cannot be 0 because it would be like a 3-digit number in that case, and you don't get multiplication as 6-digit number. That is one thing. Secondly, if D is 0, anything into 0 would be 0. So C is again 0. That is not possible because these digits are different. That is again given. So D cannot be 0. So options, one option is eliminated like that. Fine. So D can be 1 or 2. Just there you are left with 3 options. Instead of multiplying and trying out different strings, you can just try out options. And this question has repeated before and it will repeat again. ये याद ही रख लो. DEAD, this is 101, 001. ABC can be anything. Any number when multiplied by any 3-digit number multiplied by 1001 would repeat. They don't even need to be different digits. Okay. PDFs are, I'll ask them about the app. I am not aware of this situation. I'll ask them what can be done. This question was to be done only from options very easily. Our purpose is to get right answer. Fine. You don't necessarily have to reach there by right means. End is important. Means over. End over means. बोर तो नहीं हो रहे हो? बोर हो रहे हो तो बता दो. कुछ स्टोरी वोरी सुना दूंगा. It could be relevant, useful stories, not बकवास नहीं करूंगा. ये हो गया ट्राइंग आउट. याद ही रख लेना ये ABC इंटू DEAD जब भी होता है DEAD 1001 याद ही रख लो. ये आ जाएगा वापस. कभी कभी ना कभी पक्का पूछ. They have very limited things they can ask. So this could be again frequently asked question. Now next operation is division. डिवीजन में क्या करते हैं हम लोग? इट इज मल्टीप्लिकेशन ऑफ डिवीजन में डिवाइड करते हैं. इट इज रिवर्स ऑपरेशन ऑफ मल्टीप्लिकेशन, जस्ट लाइक सब्ट्रैक्शन इज रिवर्स ऑपरेशन ऑफ एडिशन. Division is nothing but repeated subtraction, like multiplication was repeated addition. Long division आता है सबको process. Are you guys familiar with the long division process? Like this वाला, ये वाला. So like 1, 2, 3, 4, 17. Can you divide this using long division? कर सकते हो कि नहीं कर सकते हैं ना? Everybody is familiar with long division. If not, we'll have practice. कर ही लो मेरे सामने. 17 का टेबल आता है कि नहीं मुझे चेक करना है. देख लो इसी साल, this year only they have asked the question where 13 का table was important. So don't think tables are not important. They wanted you to factorize 1297. You cannot factorize it without knowing 13 ka table. You have to divide this number by prime numbers. So you have to start from 2, 3, 4, then go till you find some divisors. 17 7 का क्या होता है? 119. Get 4 4 and ये ऐसे करते हैं. This is called dividend. This is called divisor. This is called quotient. This is called remainder. School की terms. कभी-कभी पूछ. The terms we should be familiar with. So dividend is equal to divisor into quotient plus remainder. We'll talk more about this particular thing because questions are getting asked like what is the remainder when you divide something by something. Remainder wala cheez we'll do when we'll study arithmetic 2 wala booklet. We have divided arithmetic into part 1 and part 2. Part 2 thoda sa difficult hai part 1 se. So we'll study that in that booklet. So remainder would be done in that booklet. But these terms, let's just be familiar with them. Dividend, divisor, quotient, remainder. And the condition is remainder is always less than divisor. 17 से बड़ा remainder नहीं हो सकता. अगर बड़ा है, then you again divide by 17 and find the remainder which is smaller than 17. Right? Remainder is always less than divisor. That is the condition. Fine. And we say that divisor is factor of this particular dividend when remainder is 0. अगर remainder 0 है, इसका मतलब है कि ये जो है, this is completely divisible or this 17 is factor of this thing, right? So instead of 1, 2, 3, 4, if I write 1, 2, 4, 4, you will get minus 44 or minus 34, this is minus 34 and you will get remainder as 0. It means 17 is a factor of 1, 2, 4, 4 or 1, 2, 4, 4 is divisible by 17. Same thing. You can use either of the language. 17 is factor of this number or this number is divisible by 17 when remainder is 0. Right? This is what division looks like. This is what long division process. और करना है थोड़ा सा long division या कर लोगे? Practice करनी है थोड़ी सी long division की to get comfortable या फिर you are already comfortable? Oh, fine. One more condition, divisor can never be 0. We don't divide by 0 in mathematics. Division by 0 is a sin. Biggest sin you can come. And I had done this in class. In my 7th or 8th standard, my teacher asked me, go and solve this question in class, in front of the class. So I went there, I solved this question, and I was standing there. She said, "Are you sure?" Well, ha, I'm bilkul. And I, I had committed that sin. She humiliated me in front of class. That was very embarrassing for me because I was good in mathematics. When I was anyway, so you don't divide by zero. Why? Because it leads to logical inconsistencies in math. We want maths to remain consistent. For example, if I divide, let's say, any number by 0, and I have some answer q, which is something. So p is equal to 0 into q. 0 into q is 0. So anything can be q can be anything, and you still get p as 0. This is inconsistent. So that is why we don't divide by 0. Anyway, as I said, Bhaskaracharya finally resolved this dilemma that was facing Brahmagupta. Brahmagupta didn't give the answer. He gave all the rules dealing with zero, like multiplication, addition, subtraction, but he could not really understand what is happening when you divide by zero. Bhaskaracharya explained it like when you are cutting, for example, a cake in half, then you cut it in 1 by 3, 1 by 4, in 1 by 5. When you keep dividing, the portion gets smaller, but number of portions increase very sharply. So you get 2 portions, 3 portions, 5, and so on. So he said that when we are having portion of thickness 0, when we are dividing by 0, we will get infinite or anant portion. That was his explanation of division by 0. Fine. What else? Division by number is divided by 10 or 100 or 1000. It will be reverse of multiplication. In multiplication, for example, this 123.1234. If this number, if you multiply by 10, decimal was going right by 1. Multiply by 100, right by 2. 1000, right by 3. Similarly, if you are dividing by 10, it will go to the left by 10. Divided by 100, go to the left by 100. Divided by 1000, go to the left by 3, and so on. If you have this 1, 2 divided by 100, decimal point is here, it will go to the left by 2. So answer would be 0.12. This is how we divide by 10, 100, 1000, and so on. You just shift the decimal point to the left, and if multiply, shift it to the right. Shift it to the right means if there is nothing, 12 into 100. Here is decimal point, shifting it to the right, shifting it to here. That is how we can envision this. Multiplication by division by n is same as multiplication by 1 by n. Right? A divided by n same as a into 1 by n. Is same thing. Division is same as reverse of multiplication. Okay. Now division with decimal point. Just to get familiarized with the division with decimal points, we have 62 divided by 2 is equal to 31, and based on that, just solve this thing. If you don't like decimal places, multiply by 100,000 or whatever the relevant factor and get rid of decimal point. So for example, you can multiply this numerator by 10 and denominator will also be multiplied by 10 and you can find the answer after that. If you are uncomfortable with decimal points. What would be this? 3.1. You can do, you can get rid of decimal points by multiplying with 10. If you are multiplying numerator by 10, you have to multiply denominator by also 10. Is same as 62 by 20. Then you can divide by 2. You get 31 by 10. 31 by 10 is simply 3.1. Or in general, if you are fine with dealing with decimal places, you can do whatever number of decimal places there in the numerator, digits after decimal place, minus whatever number of digits are there after decimal point in the denominator. Numerator माइनस डिनोमिनेटर करना. यहाँ पे न्यूमरेटर में 1 है, डिनोमिनेटर में 0 है, यहाँ पे है ना वो 1 माइनस 0 1, तो यहाँ पे 1 आएगा, 1 डिजिट आफ्टर डेसिमल. Similarly, you divide as if there is no decimal point, you get 31. Now 2 are here, यहाँ पे 0 है, 2 minus 0 2, so decimal point will be here. Here there is 0, here there is 1. 0 minus 1 is minus 1. माइनस 1 मतलब लेफ्ट की जगह पे राइट में जाएंगे, तो क्या ओके. माइनस 1 का मतलब एक 0 इधर ऐड करेंगे, डेसिमल पॉइंट वहां पे था पहले, वो शिफ्ट हो जाएगा एक से राइट. वहां पे लेफ्ट से शिफ्ट हो रहा था, यहाँ पे राइट में शिफ्ट हो जाएगा व्हेन देयर इज नेगेटिव आंसर इसका. सिमिलरली हियर यहाँ पे 0 है आफ्टर डेसिमल पॉइंट, यहाँ पे 2 है, 0 minus 2, 0 minus 2 is minus 2. Right now decimal point is here, it will shift to the right by 2, 3100, right? 2 minus 1, 1, it would be 3.1. 3 minus 3, 0, so it would be simply 31. And here 1 minus 2, minus 2, sorry, minus 1, 1, 0. If you are uncomfortable with this, just multiply by, here let's say, just get rid of the decimal point by multiplying with appropriate power of 10 and deal with the answer, deal with the question then. For example, here you can multiply numerator by 100, and so you have to multiply denominator also by 100, you get 62 divided by 200, which is equal to 31 divided by 100, which is this thing. Here you can do multiply denominator by 10, numerator also we have to multiply by 10, 620 divided by 2, which is 310. Similarly, here you can do multiply denominator by 100, numerator will also have to be multiplied by 100, which is 3100, and so on. See, what we are doing is, when we don't want to get rid of decimal points and we just want to treat it like this, we are saying in division you divide as if there is no decimal point. First you find the answer and then you add the decimal point according to this rule. Rule is whatever be the number of digits after the decimal points in the numerator, you subtract whatever number of digits are there in the denominator after decimal point, n minus d, and you add decimal point according to that. If you get negative answer, you add the appropriate number of zeros. If you get positive answer, you add the appropriate position of decimal point. That is the rule. If you are uncomfortable with that, you can just do like this. You get rid of the decimal point altogether and then divide. That is also fine. Important thing is getting the right answer. If you are comfortable with decimal points, do directly. If you are not, you can multiply by appropriate power of 10, like 10, 100, 1000, to get rid of all the decimal points in the numerator and denominator, and then operate. Question देखो CSE 2020 का. Consider the following addition problem where P, Q, R are different digits. What is the arithmetic mean of all such possible sums? चार आइडिया. एडिशन कैसे होता है? एडिशन फर्स्टली यू ऐड यूनिट्स प्लेसेस. When you are adding 4 times p, you are getting 2 in the units place here. So adding 4 times same number, you are getting 2. What could be such numbers? 1 plus 1 plus 1 plus 1, you don't get 2. 2, you get 8. This is basically p plus p plus p plus p, or 4p. No? This is 4p addition. P plus p plus p plus p. 4p. 4p at the units place should be 2. So how many options are there for p? 3 is 1. 3 into 4 is 12. So 2 आ सकता है. What else? 4 आ सकता है? No 4. 5. 5 into 4 is 20. 0. 6 into 4, 24. तो 4 आ सकता है उधर. Then 7 into 4, 28. 8 नहीं है, यहाँ पे 2 है. 8 into 4, 32 is possible because 32 में 2 आता है end में. 9 into 4, 0 into 4, 0. So only 2 possibilities are there for P. Just check. Only 2 additions you have to do. So 32 plus 42, 22, 22, that is 1, and 38, 48, 88 plus 88. Add these two things. If you are getting this kind of thing, basically different digit than P. This is 8. This is 118, right? Am I right? क्या कहा मैंने? Sorry. You have 33, 43, 33, 33. We are asked, these are two possible sums. We are asked arithmetic mean of these two numbers. Arithmetic mean is just add and divide by 2. Add 142 plus 262 and you divide by is equal to, what is it? Equal to 20. Right? Very simple question. No fancy things required. You just have to look which addition comes 2 comes at the units place. 4p, which are the possibilities where 2 is coming at the units place. Just add the sum and divide by 2 to get the mean. This was asked in 2020. Now again solve this question. Next thing, see if you can do that on the similar lines. This you can do on the similar lines. 3 into q, you get q at the units place. What are the possibilities for q then? Q can be, what 3 possibilities are there q के लिए? No. Q into 3 you get q only. 0 is there possible? 3 into 0, 0 आएगा. That is okay. 0 is one possibility. 3 into 1, no. 3 आएगा. 3 into 2, no. 3 into 3, 9 आएगा. वो भी नहीं है possible. यहाँ पे ये जहाँ पे जो है वही डिजिट यहाँ पे आना चाहिए. 3 into 4, 12, 2 आ रहा है. No. 3 into 5, 15, 5 आ रहा है. 5 is a possibility. 3 into 6, 8 आ रहा है. 3 into 7, 1 आ रहा है. 3 into 8, 4 आ रहा है. 3 into 9, these are only two possibilities. And question में क्या पूछा है? Question देखो, p plus r divided by q पूछा है, तो q 0 होगा. सोचने की भी जरूरत नहीं है हमें, q 0 होगा ही नहीं. क्वेश्चन में उसने पूछा है ये चीज. You can conclude that otherwise also that this digit will never be 0, but you don't even need to rack your brain for it, because the question asked you to divide by q, so q cannot be 0, so q has to be 5. Now your problem reduces to p into 5 into p5 p5 into 3 is equal to r 5 5. 3 into 5 15, 15 का 5 आएगा. कैरी कितना होगा? 1 होगा. 3 into p plus 1, 5 आना चाहिए, राइट. तो 3p 4 आना चाहिए एंड में. 3p plus 1 5 आना चाहिए, तो 3p शुड बी 4. कहाँ कहाँ पे आता है? 3 इंटू पी 8 में आता है, और कहीं पे आता है? पूछ रहा हूं मैं, नहीं आता? R8 आ ही नहीं सकता विवेक. देखो तुम, the two digit number is getting multiplied by बस multiplied by 3. Even if you take largest two digit number which is 99, you multiply it by 3, answer will be 297. ये नंबर तो 297 से ऊपर होगा ही नहीं, आर क्यू क्यू, तो आर 2 से ज्यादा होगा ही नहीं. आर या तो 1 होगा या 2 होगा डेफिनेटली, because this is two digit number into 3, so this number would always be less than 297. R would be 1 or 2 only, that are the only possible. Anyway, p के लिए पॉसिबिलिटीज क्या है? 3p एंड में 4 आना चाहिए. 8 एक पॉसिबिलिटी है डेफिनेटली, और कोई है कि नहीं है वो बता दो. नहीं है ना? 1 नहीं है, 2 नहीं है, 3 नहीं है, 4 नहीं है, 5 नहीं है, 6 नहीं है, 7 नहीं है, 8 है. ओनली 8 है. 8 इज द ओनली पॉसिबिलिटी. अब हो गया 85 इंटू 3, कर लो डायरेक्टली, 255. तो r is 2, p is 8, equal to 10 divided by 5. Answer is 2. Right? Okay. P is 8, right? P is 8. Then you can directly multiply, add the numbers and divide by. Just put the values, you get the answer 2. Now honestly tell me, what is the fancy knowledge required here? Nothing. Just have to see which digits. Multiplication that too by 3. 3 into q, बस एंड में q आना चाहिए, उससे ही ये हो गया क्वेश्चन. एक बार वो 5 आ गया, देन रेस्ट ऑफ द थिंग वाज केक वॉक. ये जीरो वाला पॉसिबल नहीं है. इफ यू वांट टू कंक्लूड दैट विदाउट यूजिंग द क्वेश्चन, you can see if this digit also has to be same thing. Using that fact, you can conclude that 0 cannot be come. It cannot come, because otherwise this could be 100 or 200. Both are not divisible by 3, so 0 cannot come. Right? Fine. आगे का प्रोसेस कुछ नहीं, वैल्यूज पुट इन करने हैं. p plus r divided by q. You ask question is p plus r divided by q. So p is 8, r is 2, 8 plus 2 10 divided by 5. It is 2. Answer is 2. Now see the next question, 2017 ka. A certain 3-digit number follows following characteristics. All the 3 digits are different. The number is divisible by 3, and the number on reversing the digits is also divisible by 7. How many such 3-digit numbers are there? This is not an easy question, because you have to spend a lot of time to get the right answer, but still we'll do that. मैंने क्या बोला? Whenever the question says number and reversing the number, we'll go to place value. So write the 3-digit number, write their place value. 3-digit number कोई भी ले लो. Let's take PQR. PQR is equal to 100p plus 10q plus r, and reversing it, RQP is equal to 100r plus 10q plus p. ये होगा. So it is saying that all the 3 digits are different, so PQR are different. Second, this PQR is divisible by 7, right? Third it is numbers on reversing the digit is also divisible by 7. So this number is also divisible by 7, right? So two numbers are divisible by 7. If I subtract them, would the number will still be divisible by 7? If I have, let's say 49, it is divisible by 7. Another number I have, let's say 35. if I subtract them, those two numbers, the number I get, is it divisible by 7 or not? Yes, because let's say we have 7a and we subtract it by 7b is same as 7 into a minus b. So this also number is divisible by 7 because 7 is a factor. So if I subtract these two numbers, whatever I get would still be divisible by 7. Why am I subtracting? Because I want to get rid of one variable. So I get 100p p minus p, which is 99p, and r minus 100r, which is minus 99r. I have this number as divisible by 7. This is same as 99 into p minus r. Is 99 divisible by 7? No, definitely not. So p minus r has to be divisible by 7, right? Are you following my chain of thought? Yes, no? So for p minus r to be divisible by 7, what are the possibilities? It could be 9 2, it could be 8 1, it could be 7 0, but these are 3-digit numbers, so 7 0 is not allowed. 7 0 ले लूंगा तो ये r 0 हो जाएगा, तो एक 2-digit number हो जाएगा ना. So this is not possible. So there are only two possibilities or rare reverse like 2 9 1 8. These are the only possibilities. Now for PQR, you take 9QR, 9Q, sorry, not R, 9Q, 2, 2Q9, these are the reversal, and 8, 8Q1, 1Q8. What is the condition? Both of these numbers should be divisible by 7. We have to find such Qs where such numbers are divisible by 7. So this is, after this, there is trial and error. You have to put Q values of Q and keep dividing by 7. So it is quite long in that sense, but that is how you have to do it. नहीं है, वही तो बोल रहा हूँ. This question was like that. There are some questions which are purposefully put to waste your time. It is important that you identify them. जैसे कि इस साल हमने जो last in yesterday's class we saw this one question about on divisibility. It was half a page question. It was very long, very lengthy question, and after doing everything, you still couldn't get the answer because question itself turned out to be wrong. So of course, purpose of the question was to misdirect and waste your time. But even after wasting your time, the question was wrong. So it was really important that you identify that question. Of course, most of the students would have identified it because the question itself was half a page long. So anyway, most of the students would have left it. So this is the way to do that. Important thing to note here is subtraction of two numbers if both are divisible by particular number. Their difference is also divisible by that number. So 7a minus 7b, the difference is still divisible by 7. That was the fact to be used here. Comfortable? Whatever we are doing to till now. Online students, let me know if you are comfortable, if you are following. If I am going too fast, you can let me know. If I am going too slow, you can let me know. I talked about Indian astronomy. कुछ पता है आप लोग को Indian astronomers के बारे में? Ancient Indian astronomy. हाँ हाँ, Aryabhatta is there. All these people we are talking about, Aryabhatta, Brahmagupta, Bhaskaracharya, they were all astronomers and great ones at that. I mean, with no instruments in their hands, they did great stuff. Incredible, incredible. For example, Aryabhatta knew that orbits of the planets were elliptical, and Aryabhatta gave how many days are there in the year, how much time it is 1 year, and that is accurate, so accurate that only difference with modern calculation is 3.5 minutes. To that precision, they could measure that using angles. They knew about trigonometry, sine and cosine functions, which European mathematicians were thousands of years away from that. They knew all that. Then Aryabhatta also explained that Earth rotates around itself. Aryabhatta noticed that, and that is why he said there is apparent movement, that sun move होते हुए इसीलिए दिख रहा है, that because Earth is rotating around itself. Then he could say that planets, they are reflecting the sunlight. They don't have their own light, but they are reflecting the light from the sun, which is star. Some also claim that Aryabhatta knew about Earth not being center of the universe, but rather everything is revolving around sun. But there is no definitive evidence of that. It has been rebutted by many. But somewhere down the line, at least till Bhaskaracharya's time, we knew that Earth is not the center of universe. We definitely knew that Earth is not flat. Right. Brahmagupta actually, somewhere in his Brahmasputha Siddhanta, said that every body has a mass and attracts itself. So it is the preliminary form of gravity, which was given by Newton in 15th century, like 1000 years, not 1000, but at least 700-800 years down there. So they knew about at least gravity के बारे में guess तो किया था उन्होंने. Of course, not mathematical formulation which comes with Newton, but he calculated eclipses to the very precisely. They could and explanation of why eclipses happen. Earlier, astrology believed that there are these Rahu and Ketu, which due to which eclipses happen. These were supposed to be some imaginary points in the sky, which we now know, but of course astrologers didn't know. But these astronomers, they knew that they have explained why eclipses happen. It is due to shadows. It is not due to Rahu and Ketu. Then we know equinoxes, they shift when the sun is overhead. That line shifts. That line keeps shifting. That was said by Varahamihir. Varahamihir was at the same time astrologer as well, but some form of astronomy he also. So we are inheritors of that great tradition of observation, of scientific temper, research. Anyway, so point is, all these things are relevant because the question can be asked in GS3, or you can mention all these things in your essays to make a point that we are inheritors of such a great tradition, and we should, when we are living our life in 21st century or 4th industrial revolution, they were product of their times and their values. So we should be product of our times and our values. Something like that you can say. Fine. So next topic is exponents or powers. Before that, answer these questions. Is multiple of an integer always an integer? Right? Now, is fraction of integer or division of two integers always an integer? No, 1 by 2, 1 by 3. These are not integers. These are ratios, fractions, or rational numbers. That is it. So, next topic is exponents. Should we move ahead? So, there is temple in Gwalior where we have found 0 inscribed in some accounting data. So, data is something like somebody has given something. So, it is basically some record. There is this symbol 0 used in that inscription. So, that is conclusive proof that Indians knew how to use 0 as a number in its own right, not only as a placeholder. I was asked this in one of my interviews, that what is connection of mathematics and Gwalior. So this is relevant for interviews as well, especially if you have somewhere you have mentioned mathematics in as your background or you are from Gwalior. Those interviewers are very keen about all those factoids and interesting things. They read a lot of things. So we should at least be familiar with our domains or our areas we should be familiar with. Okay, exponents. Exponents is just repeated multiplication. Addition was repeated repeated. Sorry, multiplication was repeated addition. Now exponents are repeated multiplication. We use, for example, if I want to write 2 into 2, I write it as 2 square. If I want to write 3 into 3 into 3 into 3, I write 3 raised to power 4. It just means multiplying same number those many times. That is what power means. And it is written as 3, and in the superscript we write 4, and it is read as 3 raised to 4 or 3 to the power 4. So in general, x raised to n would be x into x n times, right? You can generalize this as x would be here integer, natural number, rational number, irrational number, anything. Rules for dealing with exponents remain the same throughout the number system. It is amazingly consistent. Now let's look at the CSE 2020 question. For what value of n the sum of digits in the number 10 raised to n plus 1 is 2? यार बुकलेट कैसे नहीं मिली? क्या आ गया इसका? Most appropriate answer. What is this 10 raised to n? 10 into 10 into something. For n equal to 0, anything raised to 0 is 1 by definition. Any number, doesn't matter if it is natural, whole, irrational, real, or imaginary. Any number raised to 0 is 1. That is by definition. We assume that. So 10 raised to 0 would be 1. 1 plus 1, 2. Sum of digits is 2. No issue. So 0 is valid. But there is only, that is our cautionary tale. For other numbers, other positive integers, what is the situation? 10 raised to something. 10 raised to 2, 3, 4. What would be there? 1 followed by a bunch of zeros. And you add 1 to it. So it would be something like 1, some number of zeros at the end 1. What is sum of digits? 2. Always. Always. Why not? For positive integer. So this is true, but it is also true for 0. For only positive integers is wrong statement. It is also true for 0. Any whole number seems to be correct. And fourth is any real number. What are real numbers? It includes rational plus irrational plus all kinds of numbers. Would it be true for fractions? We have not studied powers of fractions, but for example, if n was 1 by 2, it could be root 10 plus 1. This is an irrational number. So it goes on and on. So sum of digits is not 2 here. Answer here most appropriate is any whole number. Fine. If the option had any integer, would it be correct? Any integer. Instead of whole numbers, if I had an integer here, so n could be negative or positive or 0. If n is negative, for example, 10 raised to minus 2, which is essentially 1 by 10 raised to 2 is equal to 0.01, and you add 1 to it, so we get 1.01. Sum of digits is 2. So even if it was integer, it was right. Even if it is whole number, it is also right. Most appropriate answer is whole number, because other things have only, and real number के लिए wrong है. Right. Answer is B. Any whole number. Vivek, please check now. Apparently, booklet has been uploaded. Okay. Next is square root and cube roots. Those are of special interest to us because they are used in other chapters as well. Like yesterday we saw that series square plus cube wali series IT is solved. The question was based on that. Wait for it now. You can download it before and tomorrow. Don't disconnect now. Anyway, we are towards the end. We have 5 minutes more. So squares and square roots. Squares matlab power 2. 2 into 2 is 2 ka square, which is 4. And in the reverse direction, square root of 4 is equal to 2. It can also be written as 4 ki power 1 by 2. But you can also say that minus 2 into minus 2 क्या होगा? Minus 2 का square, minus into minus, plus, minus minus plus, this is also 4. So if you are writing 4 ka square root, you write it as plus or minus. Both are possibility. Because minus 2 ka square bhi 4 hai. If you are talking about integers, there are 2 square roots of 4. This particular sign, in mathematics we use it as a radical sign and we only take positive root, but this particular thing you can take plus minus 2 roots are possible. You don't need to hair split for purposes of our course. In most of the times from options it will be very apparent kaun se roots hai. But in general 4 can have 2 roots in integers, minus 2 and plus 2, because minus 2 into minus 2 is also 4. Okay. Similarly, cube roots is when you multiply something 3 times. 2 into 2 into 2, which is equal to 2 cube is equal to 8. But what about minus 2 into minus 2 into minus 2? Minus 8. Minus into minus plus, plus into minus. 8 ka cube root if you are talking is only 2. No, minus 2 is not cube root, definitely. Okay. Now, important squares and cubes. I expect you to know cube and squares. Square still 30, cube still 15. They come in very handy. 1 का square क्या होता है? 1, 2 का square, 3 का, 9, 4 का, 16, 5 का, 25, 6 का, 36, 7 का, 49, 8 का, 64, 9 का, 81, 10 का 100, 11, 121, 12, 144, 13, 169, 14, 196, 15, 225, 16, 256, 216 is 6 cube, not 16 square. 17, 289, 18, 324, 19, 361, 361 है, 20, 400, ये तो बड़े कॉन्फिडेंस में आते हैं. 21, 441, 22, 484, 23, 529, 24, 576, 25, 625, 27, 670, नहीं 27, 26, 676, 27, 729, 28, 8, 784, 29, 841, 939. इतने तक याद कर लो, हो जाएगा याद, बहुत डिफिकल्ट नहीं है. क्यूब्स, 1 का क्यूब 1, 2 का 8, 3 का 27, 4, 64, 5, 125, 6, 216, 7, 343, 8, 512, 9, 729, 10, 1000, 11, 11 का 1331, 12 का 1728, 13 का 2197, 14, 2744 एंड 15, 3375. 15 नहीं तो कम से कम 12, 13 तक तो आ जाओ, और स्क्वायर्स में 25 तक तो आ जाओ, उतने से काम चल जाना चाहिए. You know this very famous number called as Hardy-Ramanujan number, the taxi cab number. हाँ, taxi cab number या फिर Hardy-Ramanujan. So Ramanujan, as we know, was a genius mathematician. Like he was freakishly genius, and we don't know how he used to do all those things that he did. Anyway, he was ill and he was admitted into his hospital in London. His mentor was G.H. Hardy. He came to meet Raman, and on the way he saw some taxi cab. He came in a taxi cab and he met Ramanujan and he said that I saw a very weird number, weird looking taxi number. Ramanujan said, what was so weird? Then I just didn't like it. It was 1729. 1729. Ramanujan immediately said, it's so beautiful number that it is the smallest number which is sum of cubes of two pairs of. Basically, it is 1 cube plus 12 cube, 1 cube plus 12 cube, and 9 cube plus 10 cube. The smallest such number which is sum of two pairs of cubes. So it is hard. It is said that every number was personal friend of Ramanujan. So he used to do all these things out of thin air. So this is very famous number, Hardy-Ramanujan number, or you can call this taxi cab number. That is the story behind. Okay. हाँ, वो एक नोट पढ़ लो बस, then we'll stop. Square of an integer is always positive because negative into negative will also be positive. Positive into positive is anyway positive. And 0 square is 0. So square of an integer is always positive except for 0, of course. Units place for any square will always be 1 of 0, 1, 4, 6 or 9. So basically, numbers ending with 2, 3, 7, 8 can never be squares. Why is this happening? 1 into 1, units place क्या होगा? Something into any number ending with 1, 1 into 1, units place पे 1 होगा. 2 into 2 क्या होगा? 4 होगा. 3, 9 होगा. 4, 6 होगा, 4 into 4 is 16, 5 5 होगा, 6 होगा, 7 9 होगा, 8 4 होगा, 9 1 होगा, 0 0 होगा. The unit place of any square number, there could be anything here, it doesn't matter, because unit place always be determined by unit place का product. In multiplication you multiply anything, so let's say a b c d e f g h, end में let's say 1 है and इसका square करना है, so a b c d anything 1. When you multiply these two things, it would be 1 into 1 that would come at unit place, and when you multiply by other thing there would be some zeros here, and that's how we will multiply. ये multiplication वाला method आता है ना, जब बड़े numbers multiply करते हैं, so unit place will always be 1 no matter what. The unit place of a square will always be one of these numbers. So in other words, it will never be 2, 3, 7 or 8. If you see a number which is ending in 2, 3, 7, 8, it can never be square. That is a side note. Okay, एक question करते हैं फिर रुक जाते हैं, then we'll study properties tomorrow. Question is, the age of Mr. X last year was square of a number and it would be a cube of a number next year. What is the least number of years he must wait for his age to become a cube number again? All you need to know is initial few squares and cubes. So there is some Mr. X. Last year his age was such that it was a square number. Next year it will be a cube number. Fine. So we want to find such numbers, one is square, one is cube, and their difference is 2, right? So what are the initial few cube numbers? 1, 8, 27, 64, these are initial few cube numbers. Now subtracting 2, we should, where are we getting square numbers? That is what we will check. Because last year and next year में 2 साल का अंतर है, there is 2 का gap. Here it will be negative, negative age नहीं हो सकता, age cannot be negative, so cancelled. Here 6, here 25, here 62. What is the smallest such thing? This is a cube, this is a square. Okay, question says there is some Mr. X, his age last year was a square number, any square number, and it is saying that next year his age would be cube number, some cube, doesn't matter which number. So what we are trying to do is, we are trying to find out his age next year. It could be a cube number, any of this initial few cube numbers I have written. Now what do we want? Last year ka age, it would be 2 less than next year ka age. That we want as a square number, right? So subtract 2 from everything here. 1 का माइनस हो जाएगा, तो एज नेगेटिव में नहीं हो सकता, एज कैन नॉट बी नेगेटिव. 8 का 6, 27 का 25, 64 का 62 एंड सो ऑन. आगे के नंबर देख सकते हो इफ वी डोंट फाइंड आंसर हियर, बट हियर वी आर फाइंडिंग द आंसर. So his current age is 26. Now look at the question. For how many years he has to wait for his age to again become a cube? So now his age is 26. Now his age is 26 right now. Last year 25 था, next year का 27, and he wants his age to be a cube again after 27 वाला. So next cube is 64. So next, basically how many years he has to wait for his age to become 64? 64 minus 26. What is it? Subtraction 38. That is the answer. Simple question. all you needed to know was initial few cubes and squares. थोड़ा सा आ रहा है, फीलिंग आ रहा है, थोड़ा समझ में आ रहा है. We'll stop here today. We'll start from properties of exponents tomorrow. And tomorrow, very important topic, like one of the most important topic of current age, today's age. This is last year's age. This is next year's age, 25 and 27. So current age is 26. Tomorrow we'll finish these exponents. Then we'll go for prime numbers and prime factorization. Very important. Prime numbers are used everywhere, even today. Our entire cryptography based on prime. So whenever you are using any passwords anywhere, in your mobiles, in your banks, or anywhere, you are using prime numbers. Prime numbers are that crucial. So whenever you find new prime number, there is celebration in the world that naya prime number mil gaya. Because our cryptography will become that much robust, our security will become that much robust. This is true only till quantum computing takes over. Once that comes in, everything we know, we have to throw it out. Any doubts? If you have any doubts, you can ask tomorrow as well. No problem. Tomorrow I'll give you worksheet for this chapter. You can solve it at your pace, or even you can solve it after we finish entire booklet. That is also fine. Chalo, have a good day.